This is the third lesson in the circles unit. Today I'm going to discuss inscribed angles. An inscribed angle is formed when two chords have a vertex on the circle. So a vertex on the circle means that the corner of the angle is on the circle versus on the center where it would have been for a central angle. Now there is a special relationship between this angle and the arc that it intersects. I'm going to extend this chord AB, and I'll extend this chord BC, and that corresponds to this arc AC here. Now whatever the measure of this angle, call it X, the arc will be 2 times it. I always think about it as I'm going from an inside angle to the outside, so I'm going to multiply by 2. If I'm going from the outside in, then I'm going to cut in half. So the measure of angle ABC is actually half of arc AC. We could also say that the measure of arc AB is equal to, sorry, it's not supposed to be arc AB. It's supposed to be the measure of arc AC is equal to 2 times the measure of angle ABC. So if you have something on the outside and you're going in, you're going to cut in half. If you have something on the inside and you're going out, you're going to times by 2. Now there's a special scenario where a central angle and an intercepted arc both share the same arc. So for example, in this picture, if you look here, I have angle B. Angle B intercepts this angle this arc right here. And if I outline angle A, you'll notice that that blue arc is the same as that purple arc. So it's important to look for that overlap in case you have a lot more going on in a circle. Make sure you always look to see if two angles share the same arc. We're going to do a bunch of examples with these concepts. This first one here is an inscribed angle. Now you should always ask yourself, is the vertex on the circle or is the vertex on the center? You need to determine whether it's on the circle or if it's on the center. That will determine whether it's an inscribed or a central. In this particular case, A is on the circle, which means this angle here is inscribed. Now, remember earlier we said if you have the outside arc and you need to make your way in, you're going to divide by 2. So to find that angle, the measurement of angle A is going to be half of that 80. Now you don't have to write half of 80, you could write 80 divided by 2. Whatever the case is, that will give you the same answer. So the measurement of angle A is 40 degrees in this picture. Okay, so if you're going in, you're getting smaller, you're going to cut in half. If you're going out, you're getting bigger, you're going to times by 2. Okay, so we have this 42 degrees here, and we need to ask ourselves, is that 42 degrees an inscribed angle or a central angle? Well, the answer to that is it's an inscribed angle because its vertex is on the circle. That means this arc here, there is a relationship between that intercepted arc and the inscribed angle. So just like in the previous problem, we know the inside angle, we're making our way out. So what we're going to do, oh, it's actually not like the last problem. It's different. We know the inside and we're making our way out. So if that's the case, we're going to multiply by 2. So arc WV the measurement of arc WV is going to be equal to 2 times 42. And again, we were on the inside and we were making our way out. And if you do that, you multiply by 2. So that means that arc WV is 84 degrees. Now, I just want to bring up another part to this particular problem. This purple line here is a diameter. It's a diameter because it passes through the center and endpoints are on the circle. If that is a diameter, this is a semicircle. So if we know that this blue arc is 84, we could actually end up figuring out what the rest of this is by subtracting 84 from 180, because a semicircle is 180 degrees. So you would do 180 minus 84, which leaves us with 96. That would be this purple portion, arc XW. It's not a part of the problem, but I figured I would mention it. 2 more. This next one has a lot going on, so it's really important that you pay attention to everything. First of all, we have this angle here is 35 degrees. So we need to ask ourselves, is this an inscribed or is this central? And the answer to that is it is inscribed. So if this is inscribed and we are making our way out, we're getting bigger as we go out. The measure of arc PF is going to be 2 times that 35, which is 70. So this right here is 70. Now notice we need to find the question mark. Now the question mark is only this purple arc here. Is there a relationship between the blue arc and the purple arc? There certainly is. If we look closely, we see another diameter. Diameters cut a circle in half, which means the blue arc and the pink arc here have to add to 180. So if we already know that arc PF is 70, the measure of arc PD will be 180 minus 70. And the reason why is because FD is a diameter. A diameter cuts a circle in half. Half of a circle is 180 degrees. We knew a piece was 70, which leaves us with 110 for the rest. So this question mark here is 110. Now this next one. There's a shape inside of this circle. It's a triangle. Now each vertex of the triangle is on the circle, which means we have 3 inscribed angles. This first one here is 49 degrees. If this is 49 degrees and we're making our way out, we are going to take 49 and multiply it by 2. So the measure of arc BC is going to be 2 times 49, which is 98. So this arc is 98 degrees. Now in green, this inscribed angle here is 70. So if that inscribed angle is 70 and that's on the inside and we're making our way out, this arc will be twice 70. So twice 70, so the measure of arc DB is 2 times 70, which means it's 140. Not sure what happened to the 8. Let's go back. All right, well that leaves us with that question mark up there. Leaves us with this. Now, is there a relationship between this green arc, this blue arc, and the pink arc here that I had written? There is. All 3 of those arcs should add to a 360, which means they would make up a complete circle. So the measure of arc DC is equal to 360 minus that 98 and that 140. So you can add them together and then subtract, or you could just write it like that. So the measure of arc DC is going to be 360 minus 238 for a final answer of 122. So this question mark here is 122. Okay, I have one more question here. I just quickly drew this circle whose center is D, and there are two angles here. Now again, like we stated earlier, when you look at the angles and you look at the degrees, make sure you ask yourself, is this a central angle or is this an inscribed angle? And we know that by looking at where the vertex is. The vertex here is on the center. So if it's on the center, this is a central angle. So a central angle is equal to its intercepted arc. So if this is 50, this arc AC is also 50. Now, I should have put a question mark here. This is the angle I'd like to find, angle B. Now, let's determine what type of angle that is. This is an inscribed angle. It is an inscribed angle because its vertex is on the circle. Now, if you notice, this arc is the same as that purple arc. So, I theoretically can just erase all this information because I don't need it anymore. I have that arc out there of 50. If that is 50 degrees and we are making our way in, when you make your way in, you get smaller, you cut in half, which means the measurement of angle B is going to be half of that 50, resulting with 25 degrees. Okay, so you're going to complete the 10 question quizzes. Look for semicircles, look for central angles, look for inscribed angles, and look for angles that share the same arc. When you're making your way into the circle, you cut in half. When you make your way out, you multiply by 2.